Good morning, good evening, and good afternoon. Hello, and welcome everyone to the 22nd episode of the glich.stream podcast. In today's episode, we will be demystifying technical debt. And what demystifying means is that we're going to really unpack this term. We're going to go into the details of what it means. There's a lot to talk about here. But before we do that, if you really like the content of this channel and you're benefiting from it, I would really love it if you can help me keep it flowing by supporting my efforts. You support the channel either by subscribing to Patreon or with a one-off donation, whatever you prefer. I can understand if subscription is not something you would like to do because you don't really listen to all of the episodes. You just skim through some of them once in a while, and that's completely understandable. That's what podcasts are for. They serve different audiences at different times, different interests, different periods of your life. One of the benefits, however, of becoming a member is or a member of my Patreon is joining my bi-weekly hangouts, where you join like-minded people, software engineers, and we have these jamming sessions where we talk about different topics. You bring in the agenda, you bring in the questions, you bring in whatever you'd like to discuss, and then I try to address all of these topics during this 1 hour session every couple of weeks. And by doing so, we get to, brainstorm together, share ideas, share experiences. You share with me your stories, and also you share with the rest of the group. And it's really wonderful. We've been doing it for a couple of times now, and I've been really enjoying these sessions. A lot of amazing stories and experiences are being put on the table. So you don't want to miss out on that. Huge shout out and thank you to Ali, Jad, Adib, Marwa, Tambi, and Abdurrahman for supporting this work so far. You're all amazing. Thank you very much for your donations and for your subscriptions. Now, let's switch over to our guest, Max Weinbrown, who is currently a principal software engineer at Procore. Prior to that, Max has worked at WeWork, and he has been a full-stack software engineer working in finance, edtech, and numerous other startups. He comes in with a wealth of experience, and he's got a lot of wonderful insights to share with us today. Max, welcome to the podcast. Is there anything else you'd like to share about your background?
There's nothing. I think you covered a lot of the big highlights. I'm just excited to be here talking to you, and I'm really looking forward to the topic. I think technical debt is a fun, very subjective, sometimes misunderstood, sometimes overly fixated on type of topic. So this will be great to unpack it a little bit.
100%. It depends who you ask, right? Management or the engineers. Anyway, before we dig into that, let me start with some questions about your career so far, right? If you reflect back on what you've done as a software engineer to date, would there be anything that you would change, or would you do everything the same way?
That's a great question. So I actually feel like I benefited a ton from having great mentorship early in my career. I think seeking out good mentors and finding people that you want to learn from because you see how they work and something just clicks. You watch how they do their job and you say, something about this makes more sense than the way that I'm seeing a lot of people wrestle with these types of problems. Seek those people out and find mentors for them. So that's something I benefited from very much early in my career. And I think that helped me sort of springboard a little bit and made me much more confident about which choices, which situations I wanted to be in. So I'm very grateful for that, and I wouldn't change anything about that.
Yeah, mentors definitely accelerate a lot of the different aspects and help you avoid a lot of the mistakes you would do early on. I'm very grateful for my mentors as well, whether it was solicited advice or unsolicited advice at the same time, especially early on.
Yeah, the unsolicited advice is especially key. I think, you start working with people and you need to build trust, which is, you need to believe that someone's competent. You need to believe that they're going to be honest with you, and that they have your best interests at heart. And as long as you get 2 out of 3, right, you can build trust with this person. And once you have good trust, then they can provide unsolicited advice. And they can just show up and say, hey, I saw what you were doing here. I have some ideas for you. And you could be receptive to that because you know that you got 2 out of 3, right?
100%. I love that you mentioned the dynamic because that could make or break the relationship. A lot of people who are not really experienced mentors come in with a very domineering, type of approach. They want to dictate every single step of your career or whatever you think you're doing. And it's very important for them to understand that this is not their life.
Yeah.
They can offer advice, but
there's trade-offs to be made, and there's diminishing returns in how perfect you want to get something. And a lot of people say, well, if it's wrong, then we have to spend all of our time and energy fixing it. And sometimes you might win the battle, but you're going to lose the war. And someone who's brought in thinking they have to sort of die on every hill, I guess, to keep that metaphor going, they're eventually going to lose the war, right? Because somebody's going to say, okay, well, you're too dogmatic, your approach is too academic, or it's too whatever, and it just doesn't fit our working styles, so we're just going to write you off. Whereas you could make a lot of progress by like just saying, hey, let's just move the needle, let's move everybody up, let's advance people, and then see where we are.
What was the best advice you've received? Not necessarily like something specific, but like was it more detailed, technically specific advice, or was it more the higher level, big picture type of stuff?
Yeah, so I think there's two big lessons I think that I learned from mentors in different areas. One was a big high level one early on. I was working on an application early in my career that was, unbeknownst to me, actually riddled with what we would call probably tech debt. And I didn't really know because I had like very little experience. And so, picture me working like 10, 12-hour days trying to wrestle with this thing, trying to figure out, like, even just understanding how it did the types of stuff that it did was really just a full-time job, just trying to understand it. And I remember asking this mentor for advice, and he came over and he started pointing out that this is not how this should be. And I had been told this is a great application, just go work. So nobody had clued me in to like, oh, maybe this isn't just a shortcoming of mine. Like I'm just not smart enough, or I'm just a bad engineer because I don't understand what's happening here. And obviously there's people are going to be on a scale and they're going to progress through their careers, but it's important to recognize that, sometimes you're dealing with a hard problem. It's not because you're not good enough to handle the hard problem. It's because the problem just exists.
Yeah, and it could be like too big for you to handle it
Yeah.
single-handedly. Let's put it that way.
Yeah, definitely.
Awesome. Max, what are some of your responsibilities today as a principal software engineer?
Yeah. So when I joined Procore as a staff engineer, it was more focused on one engineering team, and sort of the principal role there is defined as like a little bit more broad than that. So there's a few different engineering teams that are all under the same umbrella, and the goal is to sort of help them all align on their architectural visions, make sure that all of their deliverables can sync up, and to help guide even higher leveled engineering leadership around what are the core problems we have to resolve to get to the initiatives that we care the most about. So it's definitely like a little bit more abstract than what I'm used to, and sometimes it's a split between some hands-on work and some hands-off type of communications and more documentations and designs and things like that. But that's generally what the role is sort of about. I don't know if that tracks with the type of work that you're doing. I'm not sure actually if your work is predominantly more or less hands-on than that.
Well, I mean, it depends. I think the function is necessary irrespective of the title. And currently my work is a little bit more hands-on because I wanted it to be this way. But I've definitely taken on roles before where I had to play the software architect type of role and, do this coordination dance between different teams and across different teams, across different organizations, untangle what everybody means, unwrap the technicalities and deliver them in an easy to understand way to stakeholders who have to make decisions about them and have to reason about them. And it's a very tough position to be in because on the one hand, you're not really knee deep in the day to day. So you have to very quickly understand what's happening with the engineering teams. And you have to also avoid coming in and try to do their work for them, right? So you have to develop the understanding. And at the same time, you have to bubble up this understanding in an easy to understand manner for people who have to to call the shots on it. So yeah, I completely understand your role, and it's not easy.
Yeah, it's a balancing act, especially if you have sort of this, which I have historically had a very like lean, flat organization. Everybody should be as hands-on as they can be type of mindset. But there's a point at which the organization scales and the types of problems that they deal with scale, where you can't really do that anymore. Like a fully flat organization can't support certain types of really deep niche kind of like gnarly issues and projects in certain areas. So yeah, it's definitely a balancing act.
early on in my career, we explored building a hackerspace. And in that hackerspace, there were a lot of founding members. And every founding member had an equal voice and an equal say in how we do, what we do, so on and so forth. And that was a big catastrophe because, like, how can you move things forward if everybody has an opinion, and everybody will have an opinion about everything? Like managing by consensus is extremely difficult, and very rarely it works. And that's why.
They say this, if you ask 10 people in a room for how to do something, you'll get 11 opinions. You'll have at least as many. You have more than the number of total people. And to your point, consensus is never like the time that it takes to arrive at consensus is time wasted figuring out what is actually right. I think I heard this great analog of we spend a lot of time trying to get extremely confident. We try to get to 100% confidence. But that's because we're so afraid of what the risk of being wrong is. If we can figure out how to reduce the risk, we don't need 100% confidence. You could maybe, if the risk is 0, you don't need any confidence to just experiment and try. And then you can actually say, rather than spending the next, couple of days, couple of weeks, couple of months planning this thing and trying to make sure that everyone agrees 100%, we can just go try something today. And that's, I think, when you start getting really powerful, like iterative progress.
100%. I fully agree with you. But I also think that leaders have to be daring. Leaders have to take risks. They have to make bets, basically. Sometimes the bets will not pan out. Sometimes it will suck for the engineering teams who have to try to deliver on these bets, right? But these bets have to be made at some point. Someone has to make them. And the good leaders will own up if their bets don't pan out, and they will own up to these and they will try to do better next time. But sometimes, like, no matter how much we try to de-risk a decision, there are a lot of unknowns that are just completely uncontrollable, and then they will influence the direction, and we really cannot figure it out unless we spend so much money and resources and effort on trying to come up with all the answers, which is not always feasible.
Yeah, I totally agree. I think those bets that you're referring to, like, I love to see whether it's product owners or engineering leadership say, here's a specific bet that we're making. And what I look for in those are like, is this a measurable bet? Is it possible for this to be wrong? Right? Is there any way that we could even say, okay, a year down the road or 6 months down the road, yes, this was our bet, but we were not correct about it? Because sometimes the bets end up becoming phrased, and we do this as sometimes as entrepreneurs, people will start up something and they'll say, well, my hypothesis can't be proven wrong because it's like built into it. So for example, I think that this new product is going to become the foundation of the company in 10 years time. It's like, all right, well, how could we'd have to wait 10 years to just prove that. That's how long it would take. So this is not something that's terribly actionable. It's just like, well, I just want it to happen because I just think it's a great idea. If you say, I think we're going to get 1,000 new users if we build this feature, great. Okay, now we could see how we could de-risk it. And if we can't de-risk it beyond a certain point, we build what's left. And it's a bet. And I think that's exciting because it gives people something to look forward to. It gives them a way to say, how did we do? Let's measure it,
I love this because it's more of an informed bet as opposed to I woke up one morning and then I got this hunch that I have to do something and I don't know why, but everybody has to fall in line. Yeah, that doesn't really work. What you just said is way better. Is a way better approach for sure. All right, Max. Awesome. Let's move on to our topic of the day. So let's talk about technical debt, which is one of these umbrella terms that can carry a lot of meanings. As with everything in our industry, nothing is very clearly defined. There's really no ontology for anything. So help me a little bit understand what technical debt is from your perspective.
Right. So I be honest, I've used this term to describe probably a bunch of different related but very much different things. I think that technical debt, the origin of the concept is about how difficult is it going to be for you to modify and extend what you have, a technical product in this case, right? Technical debt is, hey, if this feature normally was going to take a week, because of other issues in the code base or other surrounding dependencies or concerns that are inherent in what we've built, it's actually going to take us 2 weeks. Well, that means that 1 week of that is the real product development. And then 1 week of that is interest that you're going to pay on this technical debt. And so one way to, the technical debt was kind of this framework that was introduced, I forget by who now, but to describe, well, you could put in maybe 2 weeks right now, just paying down sort of the technical principal, if you want to call it that. And then that feature would only take you 1 week. But if you're doing the math here, well, that's 3 weeks to pay it all down versus 2 weeks to just build the feature. So the question becomes, at what point do you decide to try to pay down your technical principal, I guess, in your technical debt?
Okay, amazing. So in your opinion, is technical debt something that is deliberate, or is it a consequence of lack of experience? Is it something strategic and tactical that managers, engineering managers, or even senior engineers can use to move faster, to move forward, to deliver on a deadline maybe? Or is it more of technical that just accumulates because we don't know what we don't know and we're just building and then we'll figure it out later?
Yeah, I think, to your point about it being used to describe a lot of different things, I think this is actually one of the reasons, because I think it can be both of those, right? It's technical debt can happen, I think, unintentionally and intentionally. So I think intentionally, it's obviously it's better to incur technical debt in an intentional way. We're going to take a shortcut in this code, or this probably should be its own service, but we're not going to build it as its own service, or whatever the case is. Intentional is definitely better, but if you never set aside time to pay down that technical debt, or if you never even document what that technical debt was and how that choice got made, it's kind of the same as just incurring it accidentally and unintentionally. So I think those are the two. I think unintentional and intentional are kind of the two different ways that teams incur technical debt. But I do agree, it can and it should be used as a tool to expedite product development, to help de-risk, things that your company is trying to do. But that definitely requires some diligence to say, okay, when are we going to use tech debt and how are we going to pay it down, and like a strategy around that.
Amazing. So I'm going to challenge these notions a little bit now, because unlike regular debt, which can be quantified and easily measured, technical debt is one of these things that is close to impossible to quantify or put a measure on. Because how do you do it? Like, is it the number of classes or number of lines of code that you have to rewrite? Is it the architecture? Is it your pipelines? What the heck is it? Like, how can you really measure it? But you mentioned something really great, which is recording the decisions made to accept a certain amount of technical debt. But how do we know that we have a lot of technical debt now and that we need to start fixing?
Yeah, that's a great question. So I think, everyone's familiar with certain types of technical debt, whether they know it or not, which is technical debt at like a code level. Maybe you say functions can't be more than so many lines, or classes can't be, or files can't be more than so many lines, or a module can't have more than so many files, or something that is very quantifiable. And then, with advanced tools that we have for different types of, whether it's dependent on your language or dependent on a particular framework that you use, tools that do all different kinds of linting and advanced versions of that in your pull request, they could tell you, hey, you have feature envy here. This thing is relying on internal details. You can start looking at more advanced versions of object design. How many public methods do you have? Things like that. Those are generally, I think, quantifiable. And usually, in my opinion, the best approach is establish a couple of sane rules and just put them on the PR and make the bot have those conversations with people. Don't try to talk to everybody about every coding potential misstepping that they might have made. Just try to let the bot do all the heavy lifting there. But to your point, there's the subjective side. I think the subjective side is very much driven by design choices, architecture choices. And I think you're alluding to, okay, well, how do we describe this? So the one framework that I'm familiar with is, using ADRs. So having even a folder that's called ADRs in your repository that just says, here are the architecture decision records. And these are the things that we, as engineers on the team, we went through and said, this is a choice that we're going to make. We considered some other stuff, but ultimately when we went this way, here's some potential risks of that down the road, or something like that. I'm sure that you've interacted probably a pretty good deal with ADRs.
Yeah, honestly, I love ADRs because they flesh out the entire idea right before even we hit the keyboard, right? A lot of teams just start building things, or they start with an epic and then they break down that epic, even if they do this type of stuff. And then what matters for them is, the task list. Yeah, that doesn't really work well in my opinion. Like, let's have a discussion around it. Let's have an ADR. The ADR could involve a spike where you do a proof of concept of something, especially if it's something you've never worked with before, right? You might want to test a few hypotheses, and you include all of these in your ADR, in your architectural decision record. You say, we tested this, and that. This generated this yielded this. These are the trade-offs that we are making right now. These trade-offs, we will accept them forever, or these trade-offs, we will basically recorrect them at a later point in time, and you define a certain timeline around that as well. And the problem with ADRs, though, and what I want to challenge you on right now, is that you have to maintain them, right? So do you actually, let's say, for example, you wrote an ADR, and then during the building process, you discovered something that nobody foresaw.
That's
now
true.
What do you do?
This is the $1 million question, right? So, this is a big problem with ADRs, but this is a big problem to solve with all documentation, right? So this is one of the reasons that the Agile Manifesto says, working software over documentation. Not to say that you don't have documentation, just that documentation isn't the primary, don't focus on that. I think that if you're going to use the ADRs, what you need is you need very clear, just in your README, the highest level documentation that you have about any particular project has to directly use the ADRs to describe how things work. If you can't use the ADRs to describe the state of the project, then the ADRs are probably missing the mark a little bit. So this is almost like event sourcing your architecture. You've got a list of choices that were made, and theoretically, at least in aggregate, they should amount to what the current state is. So you should, I think, be able to document most of the key points about how things work, why they work that way, by referring to those ADRs, which will then probably have the effect of introducing people to them and things like that. When you have to make changes, the question of do you modify existing ADRs and try to progress them through a life cycle? Do you just add, is it an append only log of ADRs? That's where I'm going to have to defer to you. I don't know I don't know which approach to take.
Me
I think both could work potentially.
Yeah, that's the thing. Like, a lot of people preach certain concepts and then they seem reasonable from a high level perspective, but in practice, the devil's in the details. Like, whenever you start practicing, that's when everything starts to creep in. Like, great, you want to maintain documentation as close as possible to code. Like, now a lot of people evangelize the concept of the C4 architecture, for example. And no, we don't want to have static diagram generation like PlantUML and whatever. We're gonna build this DSL that will allow us to dynamically on the fly generate a lot of these nice, interesting diagrams that are going to describe our architecture, and it's going to be fantastic and great because it's going to be as close as possible to the code, and we're going to maintain them as if we are maintaining code. Yeah, great.
It's great. And then you see, okay, well, this box connects to this box. And that's all you know from the diagram, right? You don't know how they're related. You don't know if it's a really gnarly connection between them or if it's just like very clean, one argument and a public method and it's all perfectly well set. There's different, there's varying degrees of connection that things can have. So just drawing a diagram really only gets you, I think, to your point so far.
100%. And the main problem that I always find is nobody wants to do this work. At some point, it all bottles down to the engineers who feel like this is grunt work or this is boring work or this is maintenance work. And nobody wants to do it, no matter what the process is. Like, we can have processes, we can have a billion notifications. One thing we use is a piece of software called Guru. It's not really designed for technical documentation, but it's designed for documentation. And there's a nice feature about Guru where it says that this document is still valid or it's now obsolete after a certain period of time. And someone has to come in and say, yes, this is still valid, right? So it's like a reminder. And the idea behind this is if it's not really valid, you either dismiss it completely or you update it and you make it valid again. Guess how many documents are updated?
None.
Yeah, very few.
Very, very few, I imagine. I mean,
right?
Here's the thing, I don't think that that's bad necessarily, right? If there's always a push for, well, what happens if I want to learn about this? I'm going to need all the documentation about everything. But the reality is you've got, most of the time in medium or large organizations, you've got everyone sort of segmented into their area of the world. If they need to go and learn about a completely different project, it's probably because they've switched teams. They're going to embed with them. They're going to learn from them. They're going to be directly talking to them. The odds that someone is going to join the company and then just go and read all the docs that all the teams have ever created, it's pretty unlikely. It's very, very unlikely. So I think that's one of the reasons that sort of that agile manifesto idea of putting the working software ahead of the documentation makes sense. How that gets back to, well, how do you manage, the architecture and the design? I think there's, a different framework there for best practices, principles, trying to align on what are the standards that we think about what a good microservice is. Do we all agree on what the actual benefits of microservices are in the first place? Why we would want them over, for example, a well-designed monolith? Like if we can't agree on that, chances are we're not going to be building great microservices that everybody aligns on, how they relate to each other and things like that. So there's a higher level alignment that I think we need to arrive at. And that's going to be, at least in my experience, that's a struggle for every organization, but it's got to be somewhere in terms of aligning on this high level work before you dig in.
Oh, that's what principal engineers and software architects are for, right? So
that's the idea. So, no pressure here.
All right, that's awesome. Max, when is the best time to address technical debt?
There's definitely, I think there's a lot of different approaches to this. There's sort of the approach that you make things easy and then you do them. I love that approach because, the idea that how long would it take you to find a book in a pile of books, right? It's going to take you as long as there are books because you just have to search through all of them. But if you go to an entire library and it's already organized, well, it's not going to take you that long. There's a specific place that every book is placed. So if you think you're going to be in the business of retrieving books pretty often, it would make sense for you to keep that list of books organized. So I definitely think there's a lot of value to saying, okay, if you're going to go do some work and you can see that work is somehow encumbered by technical debt, a great approach would be, how do we pay down some or all or a majority of that technical debt and then implement the feature that's going to sit on top of it? Because the odds are that if we're making a change here today, probably going to be making a change somewhere here next week, or we're going to benefit from this change next week or next month or 3 months from now. So I think there's usually a good case to be paying down tech debt up front, but that's not always, that may not always be ideal, especially if you're, way behind schedule and you've got lots of pressures. And I'm sure you've seen interactions like that as well.
Yeah, that is my problem with the analogy of debt as well, because it doesn't really cleanly fit this perspective here. And I'll explain why. So nobody likes to pay debt. Let's put it that way. And then we make a decision to accumulate a certain level of debt from a technical perspective. But then whenever we want to clean it up, even though we agreed why it's important to take on that debt back then, we sort of there's this expectation that we have to really justify why we need to clear up that debt. But we already decided that it's important to take on debt to move faster, but the act of cleaning it up, it's sort of implicitly embedded in, or the benefit of cleaning it up is implicitly embedded in the initial ask. Why are we really discussing right now what is the actual benefit of cleaning up the debt? It's debt.
Yeah, so, and when you say justify, who do we have to justify this to exactly? This starts getting interesting.
Yeah, there are stakeholders who are not necessarily technical, for example, who they re-challenge you, right? They re-challenge you whenever the opportunity comes in. Do we really have to pay that debt? Can we just put it under the rug somewhere and just move on with our lives? And what are we optimizing for in that case, right? This is the big question.
That's true. I
Because a
think,
lot,
yeah, I think there's a difference between, there's a difference between your de-risking work, your MVP work. I think there's an amount of, confidence around the area that maybe plays into, okay, is this is it acceptable for us to take on more debt, or is this an area where we need to start paying it down? And maybe that's something, to your point, you've got these stakeholders that have, it becomes sort of a negotiation of how much tech debt do you really want to pay down here. And I think it kind of gets back to what we were talking about earlier, where these product bets that get made, how much of a bet is it? How clear is it what the stakes are and what the risk is? Because if someone says, I think it's a great idea to build this feature because I think a lot of people are going to like it, well, we can either build an experiment that represents the feature, right? Or we can actually build a really technical debt laden version of that feature just to run the experiment. And we can maybe talk to the product managers and say, hey, we could build this pretty fast, but we're going to explicitly ask for, if you tell us that it's successful, we want another sprint to clean up the debt that we incur by getting there faster. So there's got to be an implication that the time has value. Delivering it today has to have more value than delivering it 2 weeks from now. And if that's the case, okay, let's incur some debt, and if this feature works out, we'll pay it down. If the feature doesn't work out, right, we can always just exercise the debt. That feature just disappears. So there's got to be a framework in place for having a conversation with product, I think.
so what I understand from you is
different approaches for different people. I think sometimes people are just hesitant to take on debt at all.
I understand. So what I understand a little bit is that you're saying like it varies per situation, per company, so on and so forth. But like the North Star for all of these conversations is the business case.
Yeah, I think the business case, and I think, this is kind of the difference in my mind between a prototype and a minimum viable product, right? A prototype is something that you're willing to throw out because it proves something. So if product is making a bet, if the business wants to make a bet around a particular area, I think proving that thing, proving whatever that hypothesis is, that's the most important concern. It's not about building the most scalable, most reliable, best extendable version of the thing. It's about proving the hypothesis. That's, to me, what a prototype really is. The minimum viable product is sort of, okay, what's the least, the smallest version of this that we would feel comfortable purely building onto and extending. And I think the sort of, I think product wants timeline of a prototype, but they often don't want to commit to the time spent to convert it or rebuild it into an MVP. And I do think that is the conversation. There's got to be some clear understanding of how valuable is this? What's the potential value of delivering it? And is that sensitive to time? And therefore, we can kind of come up with maybe a bit more of a framework of how much tech debt do we incur right now versus paying it down later. Do we build the prototype right now as quickly as we can, and then modify it? Or do we do something slightly different based on what we already know about the user base and what we already know about the opportunity?
Awesome. So that takes into consideration a lot of, the business hypothesis, what we're trying to achieve here, so on and so forth. How do we encourage engineers to actually also contribute to paying off the technical debt, right? Because obviously refactoring is not something a lot of people enjoy doing. That's number one. Number two, when it comes to rewards and performance and all of that stuff, it's also something very extremely hard to quantify. Oh, I worked on refactoring this. Okay, and you achieved what with it? Right? So how does that fall into the conversation of rewards and basically optimizing for that bonus at the end of the year?
Yeah, that's true. So yeah, your performance being tied to your work I think that's a difficult thing. Different companies will have different frameworks for this, but in my mind, when you're working on a team, that team is responsible for a project, and the development of that project, and I guess being having a happy product manager is like, that's a successful product team. Now, quantifying that is maybe its own thing in terms of, hey, is this a successful project in and of itself? But paying down technical debt should actually expedite the team's ability to develop the product, right? It will hopefully make it easier to fix bugs, or maybe in some cases even prevent them from happening. So you've got, say, there's a framework for this from Accelerate. You've got like the DORA metrics. You can evaluate the team based on these different ideas, like how long it takes from the time that code gets committed to the time it gets released, how often are there failures or problems in a deployment, and so on and so forth. And by using these different metrics, hopefully you can kind of quantify how the team is doing. And if there's a specific problem with them, okay, you can look at individual areas and try to do maybe a deep dive to figure out. But I think generally paying down tech debt should be part of the product life cycle. I mean, when it's not, that's when we see tech debt sort of control the entire application. And by the time it gets, nobody wants to invest in it. And then everyone goes, man, I wish everybody had invested in it. There's a tipping point where everyone goes, well, now it's so bad that we can't even do anything about it. And they start scrambling for alternative solutions and things like that. So I think product development requires that you pay down the tech debt. It's the sort of red-green refactor type mentality, or whatever your favorite framework for it is.
You know what I would love to see in software is software shelf life. Like, we have a shelf life for everything, right? Like, everything consumable. But we never have a shelf life for a piece of software or code or service or whatever. Like, what if we say that we're building this for it to survive for the next 5 years? After that, we're going to discard it, or we're going to deprecate it, or we're going to change our strategic direction. Like, why do you think this doesn't exist right now? Why do you think that everybody builds software as if it's going to live for the next 100 years?
Yeah, this is a great question. I think not obviously management doesn't want engineers to go and build something that's going to expire, right? Like, they don't like the idea that this is eventually going to need to be redone. And I mean, there are examples of software that's lived for a very long period of time, beyond what maybe people would have claimed was its original expiration date. But I think the other core problem is that a lot of engineers are building things into the application as if it's going to be for 100 years. People are building something into an application just on the offhand chance that the company wildly changes its business model the next day. And I appreciate that engineers are trying to figure out how to accommodate future problems. But it's a slight difference from saying, how do we make something that does a great job of accommodating today's problems and is flexible, so we can do work to accommodate future problems. A lot of engineers, and I guess the way that the product works with engineering, they sort of allow for a lot of abstractions that were not going to be used. The abstraction first concept is always a little bit of a red flag to me, because typically engineers love to build some flexible solution that's going to solve for every problem under the sun. And then they find out that the one problem that it was supposed to solve, it kind of misses the mark slightly. It's like, but it does these other 99 things. That's not really going to be valuable. So I think it's partially on engineers to say, this is the problem we're supposed to be solving. Let's focus on that, and then focus on making it extendable. I like the idea of a shelf life, but I feel like it has to be sort of an intermittent, or like a recurring thing, like a check-in, where, okay, every couple of months we're going to look and say, how are we doing here? Are things getting crazy? Maybe.
Yeah, I love that. I mean, every couple of months, every quarter, every year, it depends. We can figure something out. Like, also, I believe the higher the amount of engineers involved, the higher the number of users, the higher the complexity. The amount of code we introduce also increases the complexity of a product. And I think, in my perspective, that also leads to its faster deterioration. Like, I feel like the more complexity we have in a piece of software, the shorter its virtual or hypothetical shelf life is, because at some point it just becomes unmanageable, and then a lot of the people who understand that code base probably have left, switched roles, so on and so forth, and then the new engineers don't want to touch that code base and all of that stuff, which brings us to an interesting conversation. When is a good time to do a rewrite?
I personally hate rewrites. I hate rewrites because I feel like I have seen so many rewrites fail. I do think that there's stigma in working on the legacy product in a lot of organizations that is, I think, wildly unfounded. I think that the stigma is like, I've felt that before. I felt like, oh, we're going to entice you to join the company by letting you work on all the greenfield stuff, right? Which is like, oh, exciting. You want me to work on all your new stuff. You must trust me so much, and you must think so highly of me, which is great until you get there and you realize, well, 95+% of the business is generated in the legacy application that the team that has been here for the longest understands. And now you're going to be out on the fringe, asked to do something, and you're just going to go about your business, and then you're going to find out, oh, integrating it with this thing is really hard. Oh, it turns out that I didn't understand the domain model in the monolith. So rewrites, I think, are similar in the sense that if you're going to do a rewrite, you should all be aligned on exactly what was wrong with the original application or the original module that you're rewriting. And if you all understand what's wrong with that, then you probably all have ideas on how you could fix it too. So in my mind, the best time to rewrite is when you already have a very, very clear API that everyone understands. So maybe you don't rewrite an entire monolithic application, but you can sort of rewrite, or I guess in this case, extract, modules from that major application. Once that module has a very well-defined API, very clear expectations, people understand what its purpose is, or people understand how to use it, as well as the team that maintains it understands what those API aspects of that module should do. Maybe that's a great time to just write that module or rewrite that module. But yeah, Bing Bang rewrites are, they are a beast.
Yeah, definitely. I fully agree with that. I have never seen a rewrite project, let's put it this way. It's not a matter of success. It's more of a matter of answering the main premise of why it exists. So we started rewrite because we want to solve a problem. We want to make sure the teams are able to deliver faster, maybe even, be more competitive with the market, so on and so forth. But then the rewrite starts taking forever. And then we have the issue of we want to still keep adding features to the existing product, but at the same time, we have this rewrite running in parallel. Where do we add these features? Where do we invest more? And then the rewrite never sees the light of day in many of the cases that I've personally seen firsthand. But I've heard of also scenarios or situations where a rewrite was successful and it helped a company come back to the market after it has been obsolete for quite a while. And this happens when for example, some of the banking applications where like they're super old, super archaic, and then they're not able to really compete and deliver on the high demands of today's world. So some of them opted for a couple of rewrites. Some core banking solutions have been introduced that have been remodernized a little bit, so on and so forth, even though these are like massive applications. And I would not dare take on a project like that. But.
Yeah, there's a realm that I sort of steer away from. I mean, even when I worked in fintech, I don't think that anyone wanted to rewrite any core banking solutions. And it sort of gets down to like there's just methodologies that are fundamentally different. Where, for example, Lean is great for learning. Lean is about trying to learn something at all costs, right? And then you've got Agile, which is about how to build something to be as flexible as possible. And then you've got Six Sigma or something, which is how to make something as operational as possible. And you've got all these different approaches that you could have depending on the scenario. And you can't be just a lean nerd like I have been for a long time. You can't just be a lean nerd and apply that to everything, right? Lean is not going to work in situations where you need flexibility for everything. You require a different framework, and that's a different framework too. Like people sort of look at waterfall and say, well, okay, never waterfall. Well, there might be some situations where you need that level of overview up front because what you are embarking on is fundamentally so complicated that it requires that level of understanding early on.
Have you ever faced resistance from the teams you work with, the development teams you work with specifically, on clearing up technical debt?
Oh yeah, all the time. I feel like that's the that's the one thing that you can assume if you're sort of working with new teams or whether it's newer engineers or a team that you haven't worked with before. Obviously, you have to be in my mind, you have to be very careful about how you introduce suggestions. The goal is not to your earlier point, you don't go in to command and conquer the team and say, well, I have to make everything the way that it's supposed to be, and you have to listen to me because I'm correct about these things. There's going to be lots of stuff that lives in this blurry area between, okay, we can all agree that a method shouldn't have 10,000 lines. Do we all agree what constructors are supposed to be used for? Maybe not, right? And so there's certain types of things that are like, this might seem very clear to you, but it may be very, very subjective and stylistic, to another team. So you have to sort of introduce these ideas as, okay, well, if we go down this path, what would happen in this situation? I think you can try to lead people to what you think are the potential benefits of something or the pitfalls of an approach, and then provide possible scenarios. But there's always going to be pushback because some people always just want to learn and change and figure out the new thing, and some people are pretty confident about how they have their approach, and that's fine. That's a good thing. That confidence helps them mentor other people too. So that's definitely not something that's bad, but it's something you have to be mindful of if you're going to go and make suggestions, I think.
Amazing. So in order to provide this advice to different teams, you obviously have to stay relevant technically, right? How do you personally stay relevant in the field with all of these changes happening? And obviously, as you grow up the chain, your priorities shift, right? Like your priority is not to learn or pick up this technology anymore. It's dealing with different types of problems.
That's true.
And what's your advice for that?
Yeah. So, you asked earlier about sort of career progression and stuff, and we talked a little bit about the roles and being hands-on. I think the same way that you want to be hands-on as much as you can, I think that's how I am too. Obviously, there's a balance that you have to strike. I do think you try to stay hands-on if you're going to be interacting directly with these teams. But fundamentally, that's also why it's great to be in an engineering or in an IC capacity for a significant amount of time before moving into some of the more high level or hands off or even manager roles, because you need to have a really strong core foundational knowledge of these concepts if you're going to be helping people. And if you want to be seen as someone who they would reach out to even on their own once you've built trust with them. I think it's difficult to get it right because you can't speed up that process. You actually have to put the time in as an IC for a long time.
100%. A lot of people are always asking for advice. How can I become senior? How can I become staff? How can I become principal? And I would love to say to them, like, great, I can show you how you can become that, but just enjoy the time that you have when nobody's bothering you with anything but writing code and building stuff, right? So savor these moments because you're not going to have all of these opportunities down the line.
Yeah, I think someone asked me that recently and my response was, you want to switch? We'll switch. I'm just going to take tickets all day. I'm just going to write code all day. It's going to be great.
Like, how amazing is that, not to be in 100 meetings, try to explain something for 100 different types of people and coordination work.
Well, so to that, actually, I have a question for you. How do you manage your time that you spend on these things? I mean, different calendar approaches. Google Calendar's got focus time built into it now. There was other tools that have clockwise and all that stuff. I'm curious, like, how do you approach carving out time to do that type of work and stay relevant?
Personally, I'm how do you call it? I live by the calendar. So all my life, like even my personal time is governed by the calendar. So time for the gym, sacred. Time for coffee, time for lunch, time for whatever. Everything is in the calendar. And I'm not saying that this works for everybody. I'm just saying that this allows me to be highly performant and stay in control of my day. Not a lot of surprises happen and people just fall in line. Like, you want time with me? Great. No ad hoc bullshit. Put time in my calendar. All of the open slots are up for grabs, so pick one that works best for you. But leave me alone when I need my focus time. And I find that this helps me a lot. And also a tactic that I use, I have my own project board. So I have my own small Kanban board where I literally write down everything I'm working on. And that board is available for everyone to see, right? So everybody who wants to see what I'm working on at any point in time, they can just go there, see the status of every single item. If they have something they want to follow up with me on, it's right there. It's in my status on Slack. You can just click on the link and go see it. So in my opinion, if you want people to stop bothering you, you have to be transparent as much as possible. And if you are transparent with everything you're doing, then they're just not gonna latch on to every single moment they can. And be decisive, like say no, sorry, back off, this is my time. Don't be too flexible. Be flexible, but not too much.
Yeah, that's great advice. That's honestly something that I'm still working on, because I try to make my calendar sort of my governing thing, but so much ad hoc stuff just pops up, or I've set time aside for it and then it vanishes, and I find myself with an hour back, and I'm like, all right, wait, where was I on this project? So it's definitely a switch when you go from, okay, this is my ticket, to this is something a little bit more abstract than a ticket. This is a little bit different. Keeping track of that work, I think there's actually a really big opportunity for sort of coming up with strategies to organize that at larger companies. Jira does a great job of task management, but it doesn't really do a great job of, right, what are these other initiatives and how are you going to progress these initiatives and who's associated to them? That's all just tribal knowledge. And, frankly, it's 50 Slack channels and a bunch of group DMs, right? It's not something that's terribly easy for anyone to take a look at and understand.
Yeah, 100%. I fully agree with you. That's why I make sure to brief my manager all the time on what I'm doing. But yeah, 100%. It's not clear cut as we would like it to be. And no matter how much we try to organize, also there's always going to be ad hoc stuff. I'm not sure how that can be fully resolved, but I think that's part of the job, to be honest.
Yeah, that's true. I love your strategy of sort of having your own board that you surface to people. I think that's a really useful concept.
Yeah, it definitely helps a lot with stand-ups and things like that. My stand-up briefs are very short, straight to the point, succinct. I'm blocked on this. I need some support. Otherwise, this is the list of stuff I'm working on. Everybody can have a look. Max, amazing. This has been really, really great. I love our chat.
It's been my pleasure. Thank you, Bassem. It's been awesome.
Any last thoughts you would like to leave our audience with?
Fix your monolith before you try to go somewhere else. I guess that used to be my headline in LinkedIn. I've taken it down, but I'll just throw it out there again. Sort out what you can while you can.
Max, thank you very much for your time, for your insights, for your experience. And thank you very much, everyone, for listening. And we'll catch you next time.